Good afternoon, everyone. I'm Shota Deolusegun. In today's video, I want us to dissect solving the infinity of QED without renormalization. QED is quantum electrodynamics. So we're going to actually, treat the infinity of that QED. So I want us to start from here. We need to know what infinity is. Well, the way we interpret infinity might not be the ideal way, and that could be part of the problems that we have. So now we're going to actually figure out what infinity is, and then see how time energy wave model can actually help us solve the problem. Now, the interpretation of infinity based on time energy wave model is that at quantum level, infinity deals with spontaneous symmetry breaking. Spontaneous symmetry breaking. So now, what do I mean by that? Take for instance, let's say there is an observer observing an object that that is moving towards the event horizon of black hole. So when that object reaches the event horizon of the black hole, then to that observer, the object will remain static till infinity. So the reason we have this is because the reality at event horizon is spontaneous symmetry breaking. So the observer is being cut off from the subsequent reality. So the observer will not be able to see the subsequent happenings, which is the object entering into the black hole. So if we just see the object being static at that event horizon, so that could be interpreted as infinity at quantum level. You understand, because at event horizon the time energy wave is so warped to the extent that the symmetric nature of the universe is being broken, and so by being cut off from that relativistic effect, then the observer will remain in that phase of observing the as being static. That is one interpretation of infinity at quantum level. Then infinity at classical level is more or less like having a kind of infinite energy, that is having a kind of infinite energy that cannot be exhausted to travel beyond the speed of light. So by special relativity, we know that nothing can travel faster than the speed of light. So the more you try to travel, you see that the trajectory of the energy will go infinitely, and as it goes infinitely, then it will tend to be a vertical bar. So that is the trajectory of time in time energy wave model. So having that kind of infinite energy, you understand, such that having that kind of infinite energy in trying to travel beyond the speed of light, we try to make the trajectory of energy to be vertical, just as what we have in this time energy wave model. So now the infinity we have at classical level is being constrained within the speed of light limit. That is the kind of infinity interpretation that we have at classical level. So I hope you understand the difference between the classical interpretation of infinity and then quantum interpretation of infinity. Quantum interpretation of infinity is the breaking of, or let me say, it is spontaneous symmetry breaking, and as a result, the trajectory is being cut off from the observer's reality. You understand? So that is the kind of infinity we have. So the observer will observe thing being static, uh, forever. You understand? So that is the kind of infinity we have at quantum level. Then at classical, you know that already. So I just want us to have this idea of what infinity is, and then now let's dissect from this chart. Now, if we are to dissect this first diagram that we have here, this is what is known as Higgs field. Now this area, this bomb that we have here, that is a point where the Higgs field can be at spontaneous symmetry breaking. This is the spontaneous symmetry breaking potential of Higgs field. So now the particle that we have will not be at the zero level. So Higgs boson particle, they are not usually at 0 point. So they usually start from maybe above 1 or so. So that is the kind of scenario that we have there. So how can this be somehow related to time energy wave model? From time energy wave model, we know that the spontaneous symmetry breaking breaks down from, it breaks the suspension that we have around the zero region, and then it goes down. So here, this region can actually serve as, the spontaneous symmetry breaking potential of time energy wave model at non-zero energy suspension into infinity well. So, but basically, the interpretation of infinity in quantum electrodynamics is to say that, for instance, if we say we have a point here, we have x sub 1 here, then x sub 2 here. So if energy should travel from here to this point, and then let's say particle is traveling from here to this point, and it takes forever to travel that small space, then we know it is not ideal. So what we have as infinity in this quantum electrodynamics is for the fact that electrons self-energy diverges. So then the mass is seen as infinite mass, and also the charge, electrons self-energy of its charge also diverges. So that is the kind of interpretation that we have for it. And we know that it's more or less like having an electron to be in a nucleus, and for it to travel just more space that we have in the nucleus. If it is taking forever for electron to travel, we know it is not normal, because that space is not something that could require infinite energy. So that is where the problem is. Now, to solve the problem, scientists, they use renormalization. So we have Julian Schwinger. So what he did was, he came up with the idea that uncertainty cannot be excluded from the formula or the equation that one can actually use to renormalize the infinity. So in his own formula, he has what is it called? Bare mass, and then the virtual mass as well. So he has the sum of the two in his equation. So later he was able to come up with that renormalization, and renormalization is more or less like, the way I can interpret it is to say that the infinity is being truncated to something that is ideal for calculations. You understand? So that is what they did. But majority of scientists, they are not in agreement with that renormalization process, because there is a certain amount of error that one can have that you can actually ignore. but something like of infinity. Something that is of infinity is huge, and it's something that one cannot, easily ignore as such. So, is there a better way to actually tackle this infinity? So that is what we're going to see. We're going to use time energy wave model to solve this. But before we do that, let's look at the second diagram. This second diagram, we have zero region right here. This is to say that energy is zero. But in vacuum space, there is nothing like zero. So we usually have, excitation of particles, which is not at zero region. So basically, that could be interpreted as quantum fluctuation. So it is not at zero region. So now we're going to use this diagram, which is non-zero energy state of vacuum space, and then the spontaneous symmetry breaking potential of Higgs field to drive our point home. Sure, you understand? So now let's look at the second diagram. Now this second diagram that we have right here, we are using time energy wave model to illustrate the kind of fields that we can have in the system. So right now you see that we have two major fields, and then I want to explain this in such a way that we'll be able to understand this. First of all, we have gravitational field, which is the black fields, and then we have electromagnetic field. Now, if we look at this diagram up here, there is something called gauge field, and gauge field is a connection field that uniformly adjusts the undulating fields separated in space. What do I mean by that? The essence of having, like, if we want to have a situation where we have gauge symmetry, we may want to have a kind of situation that we have a field at one point, let's say this area, then have another field at this point. So how can we get to know that the operation of the field here is symmetric to the operation of the field here? We can only know that by having a connection, and that is by introducing another field, and that field is called gauge field. So the gauge field will be the connection field between the two, and the work of that field is to activate constancy trajectory from field 1 to field 2. So that is the work of gauge field. And now, because of this constancy of the gauge field, so they believe that gauge bosons should be massless. And so if we have gauge bosons to be massless, that is telling us that it will be able to travel long distance. So the fields that we have that could travel long fields will be gravitational field and electromagnetic field. So now we're going to use this time energy wave model to really analyze field and see how that can actually solve the problem for us. So now this is time energy waves field interaction. So here we are conversant with this triangle. It is equilateral triangle. So we have it being flipped here. It is still the same thing. And by being equilateral triangle, so this happens to be the constancy of light, and then constancy of gravitational field, constancy of electromagnetic field, then constancy of gravitational field. Now you see that gravitational field starts from where this suspension is. We have this suspension, and that is inflationary suspension. Inflationary suspension is more or less like suspension that we have, like at that big bang, there is going to be a rapid expansion, and then it will get to a point that the expansion will form clumps of energy, more or less like energy density, and that signifies the boundary there, which is inflationary boundary. So the clumps of energy that is being so formed is what will be later decayed by electromagnetic field. So by having this whole of this space to be filled with electromagnetic field, that means that yes, the gluon, which is the Higgs boson field for strong nuclear force, is likely to be massless. Yes, it's likely to be massless. So here we have the whole of this area being filled with electromagnetic field. Now, once it passes this inflationary suspension, then we have introduction of gravitational field. Now the balance, this gravitational field is now being extended relative to this electromagnetic field, because the clumps of energy is being decayed by electromagnetic field, and that is being, transported into gravitational field as mass worth. So we have a conservation of energy in this region. So right here, so gravitational field is so huge here because majority of what is being emitted by electromagnetic field, which is radiation that is being emitted as a result of contraction towards the low energy state, is in support of mass accumulation mechanism at classical level. And so we have gravitational field to be more than electromagnetic field here. And then you can see how this gravitational field is compensating for the loss, for that radiation loss in the electromagnetic field. So here we have that symmetric balance by these two fields. So here in this phase, which is the black hole phase, we can see as electromagnetic field is expanding. So the electromagnetic field is reducing here while it is expanding here. So we can see how the gravitational field is being contracted relative to that expanding electromagnetic field. So right now we have another suspension, and that is neutron star suspension. Now we know that by the time we have the explosion of a gigantic star, maybe supernova or supernova, whatever it is. So by the time we have that explosion, it will get reduced to neutron star, and in that neutron star we have electron being pushed into the nucleus, and that is what is really happening right here. We're going to use this vertical line bar to explain the reality of what is happening. So by having the neutron star, the electron is being compressed into the nucleus of the star, and so there will be a sudden repulsion against that gravitational compression. So we have this is where we have gravitational field. So in gravitational field we have decaying of mass to make mass light, so that the constancy of gravitational field can be so effective to elongate the process. So now the electron being crushed inside the nucleus will make the nucleus to be unstable, then the electron will be ejected out, and that is what usually results to decay of mass. So that decaying of mass in combination with gravitational field will crunch the neutron star, and then it will go into the singularity. So right now we have neutron star suspension here, we have inflationary suspension right there. So basically we are able to get what is obtainable in a black hole, because at this present phase, this where we have the vertical bar, we're able to get the reality, and we know that whatever we can interpret here will be the same for the black hole and then the Big Bang. So now let me try to use this to explain it better. So we have mass of electron, the real mass of electron outside time energy wave model. So if we put this mass worth in our formula of everything, which is the T d m equal capital Um plus 4m, if we put this there, we're going to get the classical counterpart, which is 2,277,250,000 kilograms. Now this real mass worth at classical level is being situated here, and then now we have the arbitrary suspension up here. So how do we get this arbitrary? By the time we supply this classical mass worth into that formula, because the formula feeds back on itself, so we can use the output generated as input to generate further output. So by putting this there, we're going to have strong conveying suspension, which is 5.7 times 10 raised power 48, approximately. It's an approximate value. Now this value suspends the value of weak force. Let me use this to explain this so that you will be able to understand it better. So now here we see that when we use the value, the electron mass value, we put it in place of this m and this m, we're going to get this classical counterpart. But when we now use this classical counterpart in this formula, then the value of 5.7 will suspend the value of weak conveying force at 32nd position. So here, notice that there is no point. We have 9109. So by the time we manually annihilate the suspended zeros, we're going to have it in standard form to be 9.109 times 10 raised power minus 32. Now you see that it is not 31, which is the actual real mass worth, because we have traveled to classical realm to get this classical counterpart. So we are visiting the quantum realm again, like second time. So the value will not be the same, it's going to be unique. And the reason is because there is suspension here. So by the time it travels beyond the suspension, there is going to be a kind of mass loss. And so that is why we have that. So because we are moving forward into the singularity, we can actually feel the effect of mass decay. That is the reality we have. So this is the wave amplitude at quantum level, and this is wave amplitude at classical level. So now this present phase is where reality is. Now by having the real mass worth at classical level inside the arbitrary mass worth suspension, that means that the momentum at classical level is inward. So the discrete nature of classical mass worth is buried inside. So a typical example of classical mass that we can relate with would be Earth. Then when we look at this quantum region, we have the arbitrary suspension right inside, while the real electron mass is outside. That means that the momentum is outside. So a typical example of quantum mass would be Sun, and that is why we could say that Sun keeps on ejecting what is it called? Solar wind. Solar wind. So the momentum is outward, not inward at quantum level, while the momentum is inward at classical level. So now we can see that what we have at quantum level is different from what we have at classical level. So there is asymmetric nature buried inside the symmetric nature of the universe, and that is why it is somehow difficult, for people to get the reality of the universe. You understand? So now, by the time we now get to this point, what I want us to know is that the only way we can get real mass worth of things in the universe is by traveling at the speed of time, not at the speed of light. And I've been saying that the speed of time is faster than the speed of light. Now, if we're to analyze what is happening at this present phase, we could see that when energy is being stretched to the point that it's supposed to be zero, instead for energy to be at zero energy state, we have 0.0000001423, which is the non-zero state of non-zero state or non-zero vacuum state. You understand? So that is similar to what we have here. But now, the real mass worth of electron is not even inside the time energy wave model, because electromagnetic field usually decays mass. Electromagnetic field has nothing to do with mass. So with that, we can really say, I've been trying to argue the fact that a photon could be massless, but basically by getting how electromagnetic fields work, it means that photon could be massless. And so you can see how electromagnetic field is pushing away the mass worth. And so from here we get to know that the entirety of electron mass worth is not being decayed. So we have a tiny measure of energy fluctuation at low energy states, so which is supposed to be vacuum state. So now the real mass worth is outside. What is the implication of having the real mass worth of electron outside the time energy wave model? Now that is where the infinity comes in. Now at quantum level, this spontaneous symmetric breaking is going to be, this symmetric nature is going to be broken by asymmetric nature of time, because asymmetric nature of time defines the direction of time. And so right at this present phase, the only thing that travels is time, because time by its nature is instant. And now we could see that we have the trajectory of time to be lengthy, and that could be as a result of the happenings that we have right here. So we have the time travels to connect to the electron mass worth, then it will inject it back into the system. Now imagine if this mass worth of electron is injected into this tiny space, which is 0.0000001423. So the mass worth will be so big, way more bigger than the space. So that will make it to be unstable, and then it will decay, and by decaying it will accelerate momentum into the black hole. So now the observer is being cut off here. That is if we're to interpret what infinity is at quantum level. The observer from here is being cut off at this region. So the observer could only see the instant trajectory of light by seeing that object to be static. So the symmetric nature of the initial momentum is being broken, and so the observer is being cut off from that subsequent reality. And so we can call that infinity, because the object remains static till infinity. So The classical infinity is not being able to travel beyond the speed light. I mean, not being able to travel beyond the uh, light speed. You understand? That is the kind of infinity that we have there. So it means it seems like it will take forever for any massive particle to travel beyond the light, beyond the speed of light. That is the kind of what we have. But in real sense, the symmetric nature is being broken already. You understand? So basically, we have clumps of mass, which is gravitation, at inside the black hole, which is the suspension. Then we have the clumps of energy at the inflationary suspension, which is the Big Bang inflationary suspension. So that has solved the issue of infinity. So what I'm trying to say here is that boundary measure or boundary limit is so ideal in interpreting the reality of the universe. So the infinity that we have is more or less like the only thing that I could say is elusive. You understand? But basically, the nature of infinity is just the effect of happenings, not really the reality of the universe. So the reality of the universe uses a boundary limit to get clumps, to get mass what, to get energy what that will be further decayed for momentum. That is the reality, and that is why formula of everything is able to solve the problem by traveling beyond the limit of light to get the actual mass worth of electron injected back into the system, then empower us to move into the singularity of the black hole. So instead of using renormalization, I think it's ideal to use formula of everything to get the real mass worth of electrons. So the missing piece in that reality at quantum level is the real mass worth of electron that is outside the time energy wave model, and that is what formula of everything is able to detect and inject back into the system for further reality into the black hole. So issue of infinity of quantum electrodynamics is solved by formula of everything. So that is that. I believe this video is quite informative. If you like the video, make sure you like it for real. Okay, so make sure you like the video for real, then share this video with your friends. We want this idea to travel as quickly as possible so that we can move further in science and technology. Then don't forget to subscribe to this video. So now let me quickly say this. By dissecting the reality of the universe, I usually tell you that it is Almighty God all true, and you too can attest to the fact that even one could be able to get this reality. What about the interpretation? So it is God. You understand? So to me, I believe that God wants us to know this reality, and that is why I happen to be the vessel to dish out the information to you guys. So I implore you to believe in Almighty God. Don't be deceived that there is no God. There is hand of God in everything. There is signature of God in the universe. God bless you as you fear God, as you obey God, as you honor God in everything you do. Remain blessed.